So our last video was about the carbon-oxygen cycle. And the carbon cycle is super duper important. You really need to understand the carbon cycle because so much of the class is going to be talking about it, but also just so much of our world has to do with carbon. Um, and I know we can talk about carbon, we can talk about carbon dioxide, but you really need to internalize it. It's not something abstract. We gotta make it real because everything here is made out of carbon. I mean, that tree is made out of carbon. This wood is made out of carbon, and carbon is serious stuff. I mean, that's solid. This is wood. I mean, look at this. This is hard. Where does this come from? Where does the carbon in this wood, this dense wood that you could build a house with, where does this come from? Where does this tree get all of its carbon? So you might have said it comes from the soil, and that would be incorrect actually, because a tree gets its water from the soil, it gets some important nutrients from the soil, but doesn't get any of this carbon from the soil. None of this came from the soil. All of this is almost all carbon in this dried wood, came from the air. That's where carbon comes from. And you know that because photosynthesis is carbon dioxide going in, right? And that carbon dioxide is in the air. It's not in the soil. I mean, if it gets it from the soil, it might be getting it from the air in the soil. But this wood, this dense matter comes from the air. So we need to internalize these things. We're going to draw another diagram. It's going to be the carbon cycle in its entirety. Okay, here we are back in our little drawing studio, and we're going to draw a nice big diagram here. But this is no joke. This is the carbon cycle. This is super important. So the first thing we're going to draw is we're going to draw up the whole. It's going to be big. We're going to draw a lot of stuff on here. Here's the ground, and then it's going to go down a little bit. Let's go down a little bit right here because this is an ocean on this side, and this is some ground on this side. So we're going to draw a lot up here. We're going to draw a lot down here. So the first thing I want to do is I want to make sure that we put our old diagram on here. So we're going to add our trees again. All right, here's our trees. Put a couple of trees in here because we know that trees take in carbon dioxide, right? That's called photosynthesis. And carbon comes out of trees from respiration. So the only thing, so this is just like our old diagram. It's very small. It's going to be kind of in the center of our diagram. I want to add the places where this is. So this is carbon dioxide, and it's in the atmosphere. Wherever carbon can hang out for a long period of time is a carbon sink. So this is one of the carbon sinks. It's in the atmosphere. And this is another one down here. These are the trees. So trees or just life would be another carbon sink. All right. So we already know this. This is review. But where else can carbon go? Because this tree could fall over. Right? And the carbon can, well, what's going to happen to this tree? It's dead now, so it can decay, right? And if it's decaying, that's decomposing. That's respiration by bacteria. So really, we're going to do this. So this is decay, and that's the CO2 then. That's the carbon in here going back into the atmosphere as CO2, decaying by bacteria. Or, if you're like me this summer and you're camping, you can take some of that wood, right? You make a fire, and that is kind of rapid chemical decaying called combustion. That does the same thing. And that takes carbon from the wood and puts it back into the atmosphere as CO2. So we're adding to our carbon diagram. Now, sometimes this carbon, instead of decaying right away, it might just go down into the soil. And that's actually another sink, would be the soil. But this is not decay, because if it was decaying, the carbon wouldn't go into the soil. The carbon would go back into the atmosphere. So this is just getting smaller pieces, but it's still wood or organic material, but now it's in the soil. And the soil can store a lot of organic material. That's why we call it a carbon sink. Now, so for a period of time, 200 million years, there was so much carbon being stored in shallow oceans that it ended up being preserved and turning into a fossil fuel we know as coal. Okay, so this is long-term burial. So if it was buried for a long time, I mean, like I said, 100, 200 million years. This isn't happening anymore anywhere on the planet in any great amount. That's why I made this a dotted line. This isn't even happening anymore. But it did for a long time, so we have a lot of coal. Okay, so we've kind of finished the terrestrial side of things, but this is the ocean here. We do have carbon dioxide going into the ocean by simple diffusion. So carbon dioxide will diffuse into the ocean and it'll diffuse out of the ocean. So this is really a double arrow. And so what happens to the carbon dioxide in the water? Well, we're going to be able to draw the same little carbon, this respiration photosynthesis thing down here because we have plankton and they do the same thing. So we're just going to draw a little arrow so that can go in and that can go out. So we know that the carbon oxygen cycle is happening right in there. But some of that carbon dioxide is going to be put into shells. Organisms make shells and they make a lot of shells, and then those shells die, and that's in the form of calcium carbonate. And when those shells die, they're going to make a sedimentary rock deposit called limestone. So limestone is made from shells and actually stores a lot of carbon because that's made out of calcium carbonate. So that's another sink. And this is another sink too, the shallow ocean. So the shallow ocean is a sink, but so is the deep ocean. Because some of this carbon will be carried to the deep ocean. When this plankton dies, it might settle down and go into the deep ocean, or currents will take the dissolved carbon dioxide down in there too. So, I should have made coal purple as well. So this is all a natural process. We have 7 sinks, 7 places where carbon dioxide is going to be hanging out, and that's the atmosphere, in life, mainly trees, in the soil, in coal, in the ocean, both shallow and deep, and in limestone. So you might wonder where oil is. I'm not putting it on here because it's pretty much the same as coal. Coal is a terrestrial deposit, but when life is sort of smashed and compressed down underneath the shallow sea off the coast, it generally makes oil. So oil is down here and associated with oceans. Coal is more from a terrestrial environment. So all of this is a natural process, the natural carbon cycle. So this is natural, but what we want to add now is the human influence on the carbon cycle. I'm going to do that with a different color. I'm going to do that with brown because humans mess around with this cycle. We do a few things. Some of the things you know about and some of the things you don't know about. One of the things we do is we love to burn coal, right? So we're going to take some of this coal, and what happens to that coal? That's combustion, right? So coal is going to take our not a very good color, but coal is going to take our carbon, put it back in the atmosphere. So, and what do we do mainly with coal is we make power. So we're going to say this is a coal power plant. Okay, so we got a coal power plant, and it's smoking up the sky here, putting more carbon in the atmosphere. Another thing we do is we actually we take limestone, we mine limestone, and one of the main things we do with limestone is we burn it. Again, why would we burn limestone? We tend to do that because we make cement. So when you take limestone and you burn it with coal or oil, limestone turns to cement, and cement is very useful. So we have to make we have to make another arrow going like this, right? So we've added a couple things, but we also need to change these arrows because these arrows, they're not the right size. Some of these arrows should be much bigger than others. Like I said, this arrow is barely shown because it doesn't happen anymore. And in the last 100 years, we've made this arrow quite large. So I want to thicken up some of these arrows that should be thickened up. This one certainly gets thicker. This is the coal burning arrow. What else do we thicken up here? Well, the limestone didn't have an arrow going up at all, and we make a lot of cement. So we're going to make this arrow a lot thicker. We also chop down a lot of trees and burn them, right? This is deforestation and burning. So we've taken this arrow and we've made it a lot bigger. We've also just chopped trees down and let them, even if we don't burn them, if we chop them down, then they decay more because they're dead. So this arrow has gotten bigger. One arrow that's gotten smaller is this one. Because there's fewer trees, we've actually made the photosynthesis arrow smaller. So what is some of the commonalities in the way we've changed these arrows is where are all these arrows going now? We have a lot more arrows going to the atmosphere. The only thing that we changed that's different than that is we've made the arrow coming from the atmosphere smaller. So that's a big problem. You can see that we're going to have a lot of carbon dioxide up in the atmosphere. Okay, so there's one last thing we need to look at this diagram and understand. There are several cycles. In fact, there's 3 cycles in here. One we already looked at, and this is short cycle carbon. This carbon gets taken by trees and respirates by trees. This happens very quickly. So then we're going to call this short cycle carbon. Okay, this happens relatively quickly. Days, hours, even years in the big scheme of things, this is short. What circles do you see on here that are much, much bigger, right? This circle from the atmosphere to the ocean, into shells, into limestone, and then back up. This might take, millions of years to make the limestone, right? So this is what we're going to call long cycle carbon. And then the other one, most important one, is this circle here that goes from the trees or living stuff into the soil, and then that long-term burial into the coal or oil, and then back up through the coal power plant here. This circle right here is another long cycle carbon. So short cycle carbon and long cycle carbon, very different. And this is going to be incredibly important when it comes to talking about our effect on the atmosphere. Because let's think about that for now. If we use short cycle carbon, right? Let's say we burn a tree, right? Where was that carbon a little while ago? Well, it was in a tree, which means before that, where was that carbon? It took it out of the atmosphere, right? So the carbon in the tree was just in the atmosphere. So when you use carbon that's in this cycle, you're not really adding that much carbon or any carbon to the atmosphere because that carbon was already in the atmosphere a little while ago. But think about when we burn coal. When we burn coal, how long ago was this in the atmosphere? Well, that was maybe 200 million years ago. So really, this is a one-way trip to the atmosphere. There's nothing pulling it out of the atmosphere down into making the coal. So when we burn coal, we end up adding a lot of CO2 to the atmosphere. If we grow crops, we're actually taking CO2 out of the atmosphere to grow the crops. And then when we burn them, we're just putting it back. So short cycle carbon can be utilized as a net zero carbon fuel. And that's what we're going to talk about, but it gets more complicated than that. So there's our carbon diagram. I hope it's understandable. You can rewatch the video, read about it in your notes. We've got our 7 carbon sinks. We've got some things that humans do a lot. And we also have these short cycles and long cycles. So this again is something you really need to commit to memory. We're going to be talking about it all year long.